Right, in Concept E, we're going to still be talking about covalent bonds, but we're going to be learning about nonpolar versus polar covalent bonds. Now, we talked about this for a couple of lessons and also back in our periodic table unit. Electronegativity is the ability of an atom to attract electrons in a bond or in the presence of another atom. So this property is going to influence how our shared electrons are going to actually be shared between those nonmetal atoms. Are they shared equally or unequally? So the two types that we're going to be dealing with, like I said in the beginning, are nonpolar and polar. Nonpolar, you can see these are kind of like the electron clouds. They're evenly spread between the two, meaning that they're sharing electrons equally. While the polar covalent bond, you can see that there's a greater electron density on the one on the right compared to the one on the left, meaning that the one on the right is able to attract the electrons better to it. So let's take a look at nonpolar covalent bonds. This is when electrons are shared equally. In general, this is when two nonmetal atoms have a difference in electronegativity of 0 to 0.4. So when we calculate two atoms, their difference in electronegativity has to be 0.4 or less in order to be sharing their electrons equally. So again, they both have an equal pull on their electrons. Diatomic elements are great examples of nonpolar covalent bonds because you'll end up with a difference in electronegativity of 0. Also, carbon, when it's bonded to iodine, that has only a 0.1 difference in electronegativity, so the bond between one carbon and one iodine is nonpolar. There's a couple other examples that we'll talk about in class, but again, all of these fall under that difference in electronegativity of 0.4. Now, polar covalent bonds are when atoms are sharing the electrons unequally. This is when you have a difference in electronegativity from about 0.5 to about 1.7. So it's still a covalent bond, they're still sharing, but again, there's a big enough difference where they're sharing them unequally. So the electrons spend more time with the more electronegative atom, giving it a slightly negative charge because electrons are negative, and the less electronegative atom becomes slightly positive because there's a brief moments when it doesn't have those electrons around it. So again, polar covalent bonds are going to have a direct pull on their electrons. All right, so in our polar covalent bond, I have three examples of compounds. Right here I've pulled out a single bond. So I'm looking at just one hydrogen, one oxygen, one nitrogen, one hydrogen, one carbon, and one bromine. So I can find their different electronegativities, and you can see they all fall in the range of 0.5 to 1.7. Now, what I was talking about before, a couple slides back, is they develop a slightly negative and positive charge because of that unequal sharing. So the one I have in bold is the one that has a greater electronegativity. So we're going to assign that a slightly negative charge. So this is what we use as a partial negative. And then the less electronegative would get a partial positive. And again, this just represents the fact that the electrons, while they're being shared, they're spending more time around the oxygen, which has a higher electronegativity. In this case, nitrogen will be our partially negative because it's more electronegative, and hydrogen is our partial positive, and then bromine is our partial negative, carbon is our partial positive. Again, that's based off of electronegativity values. Okay, this is called a dipole that forms, where we have, poles, negative versus a positive end. All right, that's all you need to know right now about nonpolar and polar covalent bonds, and our next lesson will focus on how these influence the polarity of an entire molecule.